of Sana classes. Today in this video, let's know about the Hamming code. So before knowing the Hamming code, we have to know what is the parity bit. So parity bits are nothing but the extra bits which are sent with the message bits to correct and detect if any errors are obtained at the receiver. Okay. So what is a Hamming code? It is a group of a code. Okay, with message bits plus parity bit. But here there is having in one conditions for how many message bits there are, how many parity bits should be sent. Okay, that condition is m less than or equal to 2 power p minus 1. So for n number of message bits, so how many m number of parity bits has to be sent is defined with this condition. Okay, for example, if you are sending 4 message bits, and if you would like to send the 2 parity bits, minus 2 minus 1, 4 less than or equal to 4 minus 3, 4 less than or equal to 1. Is it satisfied? No. So can we send 2 parity bits with 4 message bits? No. Then how many? Let's check with another number. 4 less than or equal to 4 less than or equal to 2 power 3 minus 3 minus 1. So 4 less than or equal to 8 minus 3 minus 1, 4 less than or equal to 4. Yes, it is correct. So for with 4 message bits, you can send 3 parity bits. So what is the Hamming code that we get here? So Hamming code, that is indicated with the n, is equal to m plus p, where for 4 message bits you can send 3 parity bits. Then wait, so which position you have to put message bits and the parity bits? Let's also check that. So with for 2 power n, the parity bits are allocated. For 2 power n spaces, the parity bits are allocated. So here, see, for n. So how many bits of code we get here? So 4 message bits plus 3 parity bits, we got 7-bit code. Okay. See. Okay. 1, 2, 3, 4, 5, 6 and then 7. Right. So in which position you need to put the parity, and in which positions you need to put message bits are indicated with the 2 power n, I said. So for 2 power 0, 1, so 2 power 1, 2, so 2 power 3, sorry, 2 power 2, 4. So as we are sending only 3 parity bits, so we are considering 1, 2, 4 positions for the parity. Okay. So 1 parity, 2 parity, and then 4th position for the parity, and remaining bits 3, 5, 6, 7 are for the message bits. So these are allocated for the message bits and the parity bits. So these are the grouping, how the grouping in the Hamming code is formed. So now another one, how it is. So the Hamming code is mainly used to detect and correct the errors. So for that we added the parity, and then we check the conditions, and after checking how many for the message bits and the parity bits, we have also saw so which places are allocated for the message and the parity. Clear? Now the thing we have to do is how to correct and detect. For example, you have a code. Let me tell you what written here. Okay, see, I have a 1, 2, 3, 4, 5, 6, 7. So this is my message. Okay. In this message, 1, second position and 4th positions are parity. Okay. Here I am considering even parity. Okay, fine. But at the receiver, I got this message erupted like 1, 0, 1, 1, 1, 1. So 7. Yes. At the receiver, I got this. Is it correct? No. Then how to you and me know by seeing this simply. But how the machine can know where is the mistake and how to rectify that? So for that, So for P1 and P2 and P4, there are some assigned positions, so through which it can check the mistakes and correct them accordingly. Okay. So for P4, it is allocated how many positions? In the positions like 5, 6, 7, 4, 5, 6, yes, along with 4. So 4, 5, 6 are allocated for the P4 to check. Okay. For P1, 1, 3, 5, 7. And for this, 2, 3, 6, 7. Okay. Now you have to know where is the mistake and how to rectify it. Okay. Now let's check at the position. At position 1, 3, 5, 7. At the position 1, 2, 3, 4, 5, 6 and 7. So at the position 1, 3, 5, 7. 1, 1. At the 3 we have 1. At the 5 we have 1. At the 7 we have 1. So if all are ones means it satisfied even parity, then we have to put P1 as 0. Okay. See, I'll write here clearly. See, here I'll write clearly. So position 1, 2, 3, 4, 5, 6, 7. At the receiver, I got 1, 0, 1, 1, 1, 1, 1. I said that for P4, what are the position need to be checked? 4, 5, 6, 7. At the P2, for P2, 2, 3, 6, 7. 2, 3, 6, 7. For P1, 1, 3, 5, 7. Yes, 1, 3, 5, 7. See, for 1, so P4. So for P4, see what are the positions? 4, 5, 6, 7, right? At the 4, 5, 6, 7, what we have? 1, 0, sorry, 1, 1, 0, 1. So 1, 1, 0, 1. So 1, 1, 0, 1, which are odd ones. So if there are odd ones, we have to put P4 as 1, as it is odd, the odd, but we are sending even parity. To make it even, we have to put P4 as 1. So 1, 1, 1, 1. So 4 ones, even ones, satisfied. Okay. Then next, P2, 2, 3, 6, 7. 2, 1, 3 at 3, 1, 6 at 6, 0. At 7, we have 1. So same, what we have? Odd. So odd means to make it as even, we have to put P2 as 1. And then next P1. So it for P1, 1, 3, 5, 7. So 1. So for, with 1, 1, 3, 1, 5, 1, 7, 1. So these are even, so you need to put P1 as 0. So satisfied. But at what position the mistake is occurred, then how to find and see how to find. So it is clear that with the even parity, it is clear that we got error. So we detected here, in this way we detected. Then how to correct it? Then for correcting, you have to put P4, P2 and P1. Okay. For what are the P1, P4, P2, P1 we got here, not in this which I am telling. So after checking according to the even parity, so how many ones are there here? So with that, with respect to that, how we change here has to be taken consider. So 1, 1, 0. So 1, 1, 0. Fine. If you see here 1, 1, 0. So for what? It is in binary, right? In decimal, what is its number? Its number is 6, isn't it? 4, 2, 1. So 4 plus 2, 6. So 6. At the sixth position, I have error. So what is the sixth position here? This. So as we got the error here, if it is not 0 here, then what should be the next option? If not 0, 1. If not 1, 0. So the sixth position need to be rectified. So as it is having 0, now we want to make it 1, and the final answer that we got is this. Okay, so same, I took at the transmitter I have this, but at the receiver I got this. At the sixth position I made mistake. But how to check practically? I mean, we know that by saying we told easily, but for that device internally this process is done, and in this way it is detected, and after considering this bit position it will correct it. So I think you understood the Hamming code. So Hamming code is nothing but error detecting and correcting code. So for that we need to consider message bits and the parity bits. For the parity bits allocations we consider 2 power n space. For number of the parity bits we consider this condition. Okay. For the spaces we consider 2 power n, but for the number of bits to be sent with the message bits we consider these conditions, and after satisfying this condition the number of the parities we got. So after getting the total number of bits we have group n accordingly with the 2 power n formula, and then after having after looking into one problem we come to know about the how it is detecting and correcting. So thank you for watching. Please like, share and subscribe.